Namaste students, today's experiment is Fermi energy. The aim of the experiment is like this: to determine the Fermi energy of the given metal and hence the Fermi temperature. Now what is Fermi temperature and what is Fermi energy? Now first, Fermi energy, it is the highest energy occupied by the electron at absolute 0 Kelvin. So that is called as Fermi energy. So let's understand the fundamentals of Fermi energy. Now we have matter. A substance is broadly classified into three types, say metals, that is conductors, insulators and semiconductors. This classification can be done based on many ways. So one of the classification can be done based on band gap. Now we have two bands. So for example, if I say conductors, okay, so one is conduction band, another one is valence band. So in the particularly conductors, this conduction band and valence band, they are actually merged with each other. So I will call this as the conduction band and this is the valence band. Okay. So there is no gap. Okay, that gap we call it as band gap, can be represented by Eg. So Eg is 0 in the conductors, whereas in the insulators there is a huge gap. So say if I call this is the conduction band and this is the valence band, so the band gap is high. Whereas we have the third category is semiconductors. So in the semiconductors, the gap is relatively small when compared to the insulators. Now, whenever we give energy to the electrons basically they will be sitting at the ground state. Say for example here, okay, in the valence band. So they try to move to the conduction band and participate in the conduction. So it means they need to cross a barrier. That barrier we call it as Fermi level. So basically if I consider semiconductor, so that barrier exactly lies in between the conduction band and valence band, that I will call it as Fermi level, okay, can be represented by EF. So when we come back to the conductors, since there is no gap, the conduction band and valence band, they are actually merged with each other, therefore this Fermi level lies in the conduction band. Okay. So in the conductors, the majority charge carriers are electrons. So electrons actually occupies energy levels based on a principle called Pauli exclusive principle. So suppose if I take this is the band and these are the energy levels are quantized. Since it's a pool of electrons will try to occupy from the ground state. Say for example this is the ground state. So according to Pauli exclusive principle, maximum only 2 electrons are able to occupy each energy level. Okay, that is called as Pauli exclusive principle. So maximum 2 electrons can occupy based on Pauli exclusive principle. So 2 electrons will occupy like this. Say for example last electron will occupy this level. So therefore if we give any energy, so electron goes to higher energy state. It means this has to cross this barrier. Okay, it means therefore I will call this is the highest energy level occupied by this electron, and the corresponding energy we will call it as Fermi energy. So therefore Fermi energy can be defined like this: it is the highest energy occupied by the electron, or the energy corresponding to the highest energy level occupied by the electron at absolute 0 Kelvin. So that we call it as Fermi energy. Now, what is Fermi temperature? So, Fermi temperature we define like this. Fermi temperature is, it is a temperature at which this Fermi energy will be equal to the average internal energy or average thermal energy. So, the temperature at which the Fermi energy will be equal to the average thermal energy. So, that temperature we call it as Fermi temperature. Now, in this experiment, Fermi energy can be determined by using this formula. So, the formula is EF is nothing but the Fermi energy, which is equal to NE square pi R square A divided by L square root of 2m whole square into delta R divided by delta T whole square. Now, let's understand this equation where small n is the number density, that is number of electrons per unit volume of the metal. E is the charge of electron, pi is constant 3.14, R is the radius of the metal. Suppose if we are taking in terms of wire, that is the radius of the wire. A is a constant, L is the length of the metal wire which we are using in this experiment, and m is the mass of an electron, where R is a resistance and T is a temperature. So, in this basically we are going to calculate how the resistance varies with temperature, that is, so by performing this experiment, so we are going to calculate the slope of this resistance versus temperature. So, it means I will define like this equation, I will call it as slope, where slope of resistance temperature curve. So, in the conductor, resistance directly proportional to temperature. With increase in the temperature, resistance also increases. So, this is the relationship. So, by performing the experiment, so with increase or decrease in the temperature, how resistance varies. So, by plotting the resistance versus temperature, so we get like this. Say for example, resistance is plotted along y-axis, temperature is plotted, either you can use a degree Celsius or of course you can use Kelvin also, okay, no issues. So, in the conductor or in the metal, resistance increases linearly with temperature. So, therefore, we expect a straight line, even if one or two data points which are deviating from the data points, it can be considered on the line. So, look at the maximum number of points should lie on the line such that, so we draw a straight line and we can calculate the slope. Slope basically which is equal to ABC. If I say a triangle, slope is equal to AB by BC, where AB, this is nothing but the delta R. Look at this. So, this is delta R. So, it means delta R divided by BC is the delta T. So, therefore, so by calculating the slope of this curve, so we can get the delta R by delta T and we can substitute in the formula. The formula is NE square pi R square A divided by L square root of 2m whole square into slope square. Therefore, one can calculate the Fermi energy. So, once we calculate the Fermi energy, so we can also calculate the Fermi temperature, can be represented by Tf, which is equal to EF divided by Kb. So, where Kb is the Boltzmann constant. Now, let's perform this experiment. So, you will be given with this kit and you will have a box containing patch cards and you will be given with a copper coil. So, the copper is the metal which we are considering here, copper. The copper is taken in the form of wire. The wire is wounded in the form of coil here. The length of the copper wire is 3.6 meter in this case. And also you will have one thermometer. This copper coil is inserted in the test tube, okay, in order to maintain the steady temperature. Now, so while conducting this experiment, initially you heat the water. So of course we can use a beaker also. So we don't use beaker, we will directly use a kettle. So we use the hot water here. So once water is boiled, so I'm going to boil the water now. So the temperature is goes on increases. So make sure the temperature of the coil is above 80 degrees. Now the temperature is rising. It is 74.8, 75. So once you see water is boiling, so you can switch off, so that internally the temperature increases. So I'll switch off. So temperature is already 77. It will keep on increases further. Now till then we'll just connect the circuit. Now the circuit is given here. Okay. Now 4 connections should be done here. So 4 connections. The first connection is, this is a CCS, constant current source. So let's connect this source first. So source is connected, and this is a milliammeter, and this is millivoltmeter, and this is a coil. Okay. So this is the first connection, second connection, third connection, and 4 connections. Okay. Now, so positive of the milliammeter is connected to here. Negative of the milliammeter is connected to negative here. Then positive of the millivoltmeter is connected to positive, and negative is connected to negative voltmeter. Okay. Now here, so this coil has a 2 terminals, so we will connect these 2 terminals here. It means, so we have connected the coil across these terminals. So 4 connections are very important. One is the source, milliammeter, millivoltmeter, and the coil. So now it's complete in circuit. So even the circuit can be seen like this. So we have constant source, current source, and milliammeter. This is milliammeter, and millivoltmeter, and this is the coil. Now let's switch on this. Now here in this experiment, so we are actually going with cooling method. There is heating method also, but heating method we will not go, because so changes are abrupt, so we cannot get the steady values. Therefore, it's good to go with the cooling method. So in the cooling method, what we will do, so we will heat the water. Say temperature is above 80-85 degrees Celsius. Now you need to wait until it comes to a particular temperature, say for example 85 degrees Celsius. So in this experiment, so tabular column is like this. So temperature degree Celsius. Of course you can convert into Kelvin also. And we are going to measure what is a current and what is a voltage here. So current and voltage. So by measuring the current and voltage, so we can calculate the resistance by using Ohm's law. So according to Ohm's law is V is equal to IR, therefore R is equal to V by I. So this unit is milliampere, and here it is millivolts. So say start your experiment at 85 degrees Celsius, and you continue this experiment up to 50 degrees Celsius in steps of 5 degree Celsius reduction in the temperature. So it means start at 85 degrees Celsius, note down what is the current and voltage, then wait until 80 degrees Celsius, then is 75, 70, 65, 60, 55, 50. So it is always recommended to start at 80 degrees Celsius. In case if the temperature is above 85, you can also consider starting at 85 degrees Celsius also. Okay. Fine. Now once it is at 85 degrees Celsius, now the temperature is 86.3. I think we need to wait for some time. So once it is 85 degrees Celsius, so note down what is the current and voltage. Now it is 85.7, 85.6, 85.5, 85.4, 85.3, 85.2, 85.2, 85.1 and 85. 85, for 85 the current is 47.5 milliampere and voltage is 24.2 millivolts. So once you have current and voltage, so using Ohm's law you can calculate the resistance value. So resistance value can be calculated like this. Now let's calculate what is the resistance for this reading, because we need to wait until it comes to 80 degree. We have taken 85, next value will be for 80. Now let's calculate. So it is millivolt divided by milliampere, so milli will get cancelled. So therefore it is 24.2, that is V, divided by I is 47.5. Now it will be 0.5094733684. So we always recommend to consider up to 3 decimal points. Okay. So I am going to consider, let's say for example here 0.509. Okay. So it is always consider up to 3 decimal places. So like this, so you need to conduct the experiment, and for every 5 degree reduction in the temperature, so note down the current and voltage and calculate the resistance value. So for this experiment, so we have current and voltage values here like this. So for 80 it will be so we can measure, say for example it will be reducing. So finally I will consider like this 0.478 for that is for 80, and 0.471 for 75 and 70, 0.463, 0.455, 0.449, 0.443, 0.435. Like this you will have a values. Now what you should do, so once you have a resistance versus temperature, plot the graph R versus temperature. So you will get a straight line and calculate the slope of this. So from the slope you can calculate what is delta R by delta T. Okay. So since the variation in the resistance is very small, therefore it is always recommended to consider up to 3 decimal places and plot the graph like this. And for this values the graph looks like this. So we have plotted here. So the graph looks like this. Now look at this. So 1, 2, 3, 4. So almost 4 data points are actually lying on the line. So 1 or 2 data points are actually, there is a small deviation. So that can be considered. Since it is called as least square fit method, so any deviation can be neglected. So once you can calculate delta R by delta T, that is the slope, substitute back in the formula The formula is like this: sin E square pi r square A by L root 2m whole square into slope square. So we can calculate the Fermi energy. Once you calculate the Fermi energy, so Fermi temperature can be calculated. Tf is equal to F by kT. Thank you.